Hey there. The purpose of this video is to help you find the domain and range of piecewise functions. So domain, remember, is the set of all possible x's, and range is the set of all possible y's. So when I'm looking at the domain of a function, I think of it as running a vertical line across the graph and seeing if there are any what the points are that line hits the graph at. So if I took a vertical line and ran it across this first graph, to the left of where the graph is, it would still be hitting the graph, right? Because there's an arrow pointing to the left. If I drag this vertical line through the graph, there's not a single value at which the vertical line doesn't hit the graph. Since it hits at every single x value, then the domain of that would be all real numbers. And remember, the symbol for all real numbers is the double bar R. If I was checking the range, then I would run a horizontal line across the graph. So let's see. Horizontal line hits the graph at all points, so the range is also all real numbers. Now, since it's range, instead of saying x is an element of the real number set, I would write y as an element of the real number set. So if I look at the second graph, this one doesn't have arrows on it, right? So what we see is what we have for the actual values on that graph. So I'm going to grab my vertical line. Notice if I put it here, it's not hitting the graph yet, not hitting the graph. The first place it hits the graph is at 0. And then it hits at every value between 0 and 2. And then when it hits 2, it's still hitting the graph because of this point at 2, 3. Still hitting, still hitting, still hitting, still hitting, still hitting, still hitting, still hitting. And right here, it stops hitting the graph. So what I've got there is a domain that started at 0 and included it, but ended at 3 and didn't include that. Now, let me run my horizontal line across the graph. See, not hitting, not hitting, not hitting, not hitting, not hitting, not hitting. It hits at 1. But it doesn't hit at any numbers between 1 and 3. Hits again at 3. Doesn't hit at any numbers between 3 and 5, but hits again at 5. And doesn't hit any numbers after that. So basically, the range on this one, even though it's continuous, is only a list of numbers because it only hits at those 3 values. So I'm going to write the range, and I'm going to write it as a list of numbers, 1, 3, and 5. Now, third graph. Domain first. Have an arrow, so it's hitting x values before. X values, all hitting, all hitting, all hitting. Hits here at the point -1, 1. Sorry, -1, -1. Hits. So the domain of this is all real numbers. And then the range, let me grab my range line. Arrow pointing downward, so it hits points that you can't see below the graph. Hits. Well, here it hits at 2 different places, but that means it's not 1-to-1, right? It's still a function because it passes the vertical line test. Hits. And then right here is where it stops, and it doesn't hit there. So the range is when y is less than 3. Now, those are all inequality notation, except for the first one because you don't really need an inequality for that. The thing we were talking about in class at the end was interval notation. So interval notation, you write the intervals between which the graph falls, and if an endpoint is included, you put a bracket, and if it's not included, you put a parenthesis. So for this first one, if I were writing this in interval notation, the domain would fall between basically -infinity and +infinity. And you can never actually include either of those because you can't actually reach the infinities. So I would put parentheses around that. And the range would be the same, but with y's. When I come to this second graph, if I wanted to write this in interval notation, the domain x is between 0 and 3. I include 0 so it gets a bracket, but I don't include 3, so it gets a parenthesis. The range, however, because it's a list of numbers and not like an interval of numbers, that's still going to be the same way of writing it that I wrote it the first time. You can't write it in interval notation if it's just a list of numbers, because it's not an interval. So for this third graph, if I wrote this in interval notation, the domain would go from negative infinity to positive infinity, not including either one. And the range would be less than 3. So that would start at negative infinity, but it would only get up to 3, never include an infinity, and we don't include 3 here. So hopefully that helps with finding domain and range of functions and with working with interval notation.